Oh, first of all, let me give you the answer to the pressure.
Yeah.
Why is the pressure higher here than it is up there? It's gravity. It's because of gravity.
Right. Gravity, bro. I'm so far removed from the concept of fucking gravity that I forgot all about it when you
Gravity sucks.
should have been obvious, right? Hilarious. I totally forgot that you guys are you guys do that. Okay, so
the amazing thing is that we all know that gravity is a thing. You know it as well, right?
We
you
all
just don't like the word. Is that
it? No. It's not the word, bro. Like when I'm holding something in my hand right now, I drop it, it falls. Like I'm not saying that that's just not true, right? Because that's ridiculous. That's ridiculous. What I'm saying is,
we all agree.
What's that?
We all agree.
What
on that, right?
Oh,
like something is stuff falls. Right. Yeah, I'm not going to argue that. Okay.
I know. Yeah. Dumb Jezza. I'm just kind of messing around. When I talk like that, I'm just. but I did forget that the gravity is the answer on that because in my view of how gravity works, it's not pulling down on air molecules or anything like that or creating any sort of barrier with the gas or whatever because the force is too weak that we experience.
Okay.
So you guys attribute gravity to solve a lot of problems that nobody else can verify. So that's
okay. So can we dig into that then?
Yeah, sure.
Problems nobody else can verify.
Right.
What have you done to attempt to verify this?
Nothing, but hear me out.
Okay, hold on. I want to pause for a moment and just stress that you started with nothing.
I know. So just hear me out. I've watched videos.
You've watched videos from flat earthers.
No, I've watched videos from other people. Like
okay, go for it then. Take it away.
Okay, all right. So this force is super weak, right? If you take a helium balloon and fill it halfway, the whole deal where you can get it to just stay level. Pretty much, it's not pulling down or floating up, right? So if gravity's not pulling it down right here on the surface where it would be strongest, right? Closest, like because it's pulling us down to the. It would be strongest on the ground, right?
No, not right. Sorry.
Okay.
Gravity is always there. It's not. There's no time when it's not there.
Okay. So the half-filled helium balloon would be affected by it if it was always pulling down on it, but it's not. And then so you go high. Okay.
Who says it's not? Who said that?
The fact that you see it not getting pulled down.
Have you heard of something called buoyancy?
Yeah. So that force of buoyancy is overcoming a force that's holding us on a spinning ball that's bending bending water around a curve as it spins, and that's super strong, blah blah blah. But it can't pull a balloon down, bro. Like that's where we disconnect with the gravity affecting in the atmosphere.
That's why. Do you know why? Do you know why you disconnect on that?
No.
But I don't disconnect. I don't disconnect on that at all. But you do. Why is that?
I don't know why you don't. But for me, it's just there's nothing to. If it doesn't pull it down, then there's, then what is it doing, right? There's got to be, if it's that weak, but the sun pulls us as it goes through, space and shit. Like that doesn't make any sense to me. That it's that strong.
Let me postulate why I think it doesn't bother me, but it does bother you.
Okay.
When I had that question at some point, I said, gosh, that's strange. Why doesn't a helium balloon sink? And then I looked for the answer. And then I found the answer. And I learned the answer. Now I know the answer. And you didn't.
It doesn't overcome it because the strength of gravity isn't strong enough to.
You didn't look for the answer. You just looked for other people who think like you who didn't look for the answer either.
Okay, fair.
Right?
Okay.
Because I have the answer. It wasn't even hard for me to find.
Your answer, though, is that a weaker force
What weaker force? Gravity causes buoyancy.
Gravity causes
buoyancy. The force we call buoyancy, what makes helium balloons float, is the logical outcome of gravity. You can't have gravity without buoyancy.
But buoyancy is, you're saying buoyancy is what causes gravity, or gravity is what causes buoyancy.
Yes.
Okay. I'll have to look further into
that. As soon as you introduce gravity and you understand what gravity is doing, and then you work the math on it, you say, lo and behold, if it works like this, helium balloons should float. And you go, oh, you know what? Helium balloons do float. And you're like, oh, okay, yeah, that's cool. Right? The difference is you haven't done that. You haven't honestly said, what causes this buoyancy thing? I want to know the answer. You have instead said, this buoyancy thing is impossible, and I'm going with that.
No, I'm not saying that. I just don't know that gravity causes buoyancy in the way that you're saying it does, because if it's so strong, how could it be so weak? You know, like, that doesn't make any sense to me, because how does buoyancy overcome it, though? Right?
How does buoyancy overcome gravity?
Gravity. You say it creates.
I can lift this pen.
So it creates
this pen, but if I let go, it falls. Right?
Okay.
How can I overcome gravity?
But that same, but you're saying that same force, quote unquote, is what's keeping the moon going around us. But you can lift the pin up, but the moon can't, like, fuck off or get spun out, during our rotation or anything, because it's strong enough to hold the moon, but it can't pull a balloon down. That's where I'm like, I don't know what the fuck this is.
Right. And again, I'm going to stress it, because this is my whole point, is the difference between your approach and my approach. My approach is to say, that's a good question. Let's go find that answer. And I have noticed that you haven't done that. You haven't gone to find the answer.
Bro, because there's no need to. Listen to what that guy just, the
moon's
more.
Hold on. There's no need to. You've already decided you will not accept the answer when you get it. Is that correct?
No, my bad. I was reading chat.
There's a need to find the answer.
Hold on one sec.
Let me ask you a different question. Let me spin this a different way.
One sec. I was reading chat, and I wanted to respond to something, so I just brushed
what
whatever you were saying aside. No, it's fine. It was just guy was saying the moon's more massive than the pin. So what does that mean, man? How does the moon not get pulled down, but the fucking pin doesn't?
Okay. I mean, I didn't really want to get this turn this into some kind of lecture about gravity, but let me give you the answer first, and then let's get back to the differences in approach. The force of gravity is proportional to the mass of the object. Have you heard that before?
Yes.
So I take the mass of the object and I multiply that times the mass of the Earth. So
I don't believe that you guys
the mass of a pen multiplied times the Earth is one number. The mass of the moon multiplied times the mass of the Earth is a different number. It's a bigger number. So you get bigger forces on bigger objects. Right? I mean, a 20-pound weight weighs more than my pen. And you understand that that's both gravity, right?
I agree that it's weight.
It's weight. And this is the thing. When you grew up, you had no problem calling that gravity.
No. Because
so
I didn't think about
a dirty word now.
It's not that it's a dirty word. It's how you're saying that it works, right? You're saying, oh, well, how'd you measure the mass of the Earth, dude? I mean, because this goes back to where you linked me the Cavendish experiment, and you know what I think of that, man. That's
right.
So
okay,
so hold on a sec. You've got
too far out of it.
Hold on. You've got these numbers to work out this equation and stuff, but like I just don't think that that any of that math has been confirmed beyond what, like when you drop something like it that's it. When you say that it applies to the moon and all this shit,
Mhm.
th- I'm just like, I don't know about that, man. So so
Okay,
let-
well,
so
I
wait
mean,
so
it's
wait
cool that you
let
would say,
let
"I
let,
don't know about that."
let me
That's cool.
let me follow up on this real quick.
Okay,
So in your version, so we're talking about Newton gravity, right? Where it's mass
sure.
attracted to mass.
Yeah.
So how does Einstein gravity factor into this pin equation and moon equation, right? So
Mhm.
or even the helium balloon, for example. So the
Uh-huh.
helium balloon that's being neutral, if Einstein, what does Einstein have to say about the neutral balloon? Like how does that work? Because
Einstein
does
agrees.
di- agrees that the
Agrees.
agrees with what that it should stay there and
That
it's all good
with Newton.
and okay.
Einstein's equations are identical to Newton's equations here on Earth. Okay, let me be precise. They are
Yeah.
so close to identical that it would be really ridiculous for us to try to show the difference.
Well, if it's the bending of space-time, then, like, is the
Mhm.
balloon bending? Like, what does that mean exactly? Like, is it a terminology thing that I'm having an issue with? Or is
Yeah.
it because
Yeah, it is.
yeah, well, I mean, tell me about it because from my understanding, you're saying that the moon, let's just use the moon for this example real quick.
Okay.
So you're saying the moon is attracted to the Earth's mass, right?
Mhm.
But it's also not that at all. It's the mass of the Earth that's bending a fabric of space-time. Like, what? Like,
Um,
like, so but
it's a
you're saying
good topic. It's
but
an
you're saying that
interesting topic.
you're saying that they're the same because of math, even though those are 2 different things. Because one of those things is a force pulling on something to attract it,
Mhm.
and the other one is something bending along a curve,
Sure.
right? So is the moon bending along a curve, or is it being pulled, like, what the fuck is going on up there, dog, in your
Um,
model?
uh,
Or, from your
that's a really
understanding?
interesting topic, and I will promise to come back and get to it if
Okay.
you want to still. But first, before we do, tap the brakes a little bit and let's go
Okay.
back to that previous thing, the previous example I mentioned, and I'm going to say that applies here again. The previous example was if the ISS is fake, does that mean the Earth is flat? And we agreed no. No, it
No.
doesn't. So
No.
it's just not relevant, right? Okay, so let's do that again here. And we say, are you trying to tell me that Einstein says when I drop this pen, it won't fall? Is that
No,
what you're telling me?
no, I'm just asking you what,
So
like,
you know
I'm
that
I
Einstein
I'm asking you
agrees.
is the
You
pen
know,
falling or is it bending along a curve?
you know that whatever words we use to describe it, Einstein agrees if I drop this pen, it will fall. Right? Einstein is on board with that.
Is it falling toward the center of the earth or is it bending around a curve though? Because that's where I'm
It's,
stuck. And if that's where I'm going full retard, just tell me. And
you're not going full retard. What
because,
you're doing is you're stuck in a mental
yeah, no, I
dead end. And the
gotcha.
dead end you shouldn't have even gone into because it's irrelevant. It does not matter whether there's some kind of bending of space-time or not. The pen falls.
Right.
You
Um,
agree the pen falls. I agree the pen falls. Newton said the pen falls. Einstein says the pen falls. So let's say we can prove Einstein is wrong. Oh, Einstein is wrong. It's not bending space-time. Does that change anything?
no, I guess not.
It doesn't. What if we say Newton was wrong, Einstein was right? Does that change anything?
No, but
So why are we even talking about it?
I don't know, man. I'm just trying to understand the stuff that I'm stuck on, bro. Because I'm stuck on this shit too, and there's no one
Okay.
to really ask about, Einstein shit because most flat earthers don't have PhDs in that shit, and they're just kind of going off of
All
that
right.
shit. That's why I'm here, man. I'm here to get some questions answered, dude.
And I really appreciate you being here and putting up with me. I'm getting too preachy sometimes.
No, you're good,
So
man. You're
let
you're
me
trying to
let
move
me
it
tell you my
along.
hypothesis again, and then if you want to know the answer, I'll tell you your answer. My hypothesis is that the flat Earth folks, um, they realize, as you do, that it doesn't matter whether Einstein or Newton agree. It doesn't matter. and yet they really want to push it and they're really upset about it. But they know that it doesn't matter. And I think that's dishonesty. What do you think?
I think that it does matter because you're attributing that stuff to the stuff in this. You're attributing to what we see on Earth to how the sky clock or the sky works, right?
Right.
And that's
Well, but we understand that Newton and Einstein both describe the sky clock exactly the same. We agree on that?
I'm sorry,
they use different words. One of them
I'm
said bendy space-time. One of them said mass attracts mass, right?
So what? Yeah. Okay.
But that they both describe the sky clock moving in the same way.
Yes.
Okay. So in what way does their different wording have anything to do with what's true and what's not true?
Not sure, man.
I'm not either. And I think that to me, I'm taking that as a sign that flat Earth is not a serious, it's not an honest investigation. It's a deliberately dishonest distraction from a conversation they don't want to have, which is that the way that the sky clock moves. They don't want to talk about the way the sky clock moves. They want to talk about the differences between Einstein and Newton instead. What do you think about that?
Yeah, I'd say there's a considerable amount of talk about where those two differ and how because I've heard one argument where they say that Einstein's theory superseded Newton's theory, so therefore the Newton stuff doesn't. It's fucking confusing to figure all that shit out. So
can we agree? Can we agree that assuming Einstein does supersede Newton, that does not mean gravity doesn't make the pen drop?
Well, I would say what's causing the gravity though. You're saying it's based on the size of the mass of the Earth, right? That's where you're saying that, and I'm saying that that's not that mass doesn't attract a mass like that. So that doesn't. So just because you have math equations and stuff for it, that that it doesn't apply the same way.
Okay. Why doesn't it work? I have an equation, right?
Well, not that the equation doesn't work, but you can build equations for anything, bro. It's just numbers and shit and equations to describe things. I've heard math people that aren't flat earthers say shit like, I can make a mathematical equation to, that says a table's round. So that doesn't. So like you could do it for the Earth too, right? Like it doesn't.
Well, there's a difference. If I make a mathematical equation that says my table is round, and I'm sorry
that the surface of the table
round, right? If I do a measurement and I say the table isn't round, what do I do with that equation?
I don't know, man.
I throw it away. I say this is a crappy equation.
You would think that that's what they do.
That is what we do.
Allegedly,
right? Do you agree that a larger object of the same material weighs more than a smaller object of the same material?
Yes.
So the mass of the material increases its weight.
Okay.
So weight is proportional to mass.
Okay.
Okay, cool. That's what the equation says. So it works. Right?
Yeah, but here's the thing, man. Back to the attracting stuff, right?
Okay.
Like, do you have, aside from the Cavendish, is there any other thing? Because there's just nothing there, man. I just can't see like this thing I'm holding in my hand is attracting to my cell phone, and my cell phone's also attracting to that, and like, but you can never see that. So all this math shit that you guys have for that to describe what's going on in the sky I feel like it applies the same way. It's just shit you guys are saying,
Sarav says, I'm just going to read this. I don't know if you're reading the chat. I really wish I could talk to this guy after my exams get over. Yeah, it's exam season for us as well. I don't have to take the exams, so I'm chilling tonight. But yeah, Alan, Sarav would like to talk to you later.
Yeah, man. If you want to talk to me, I'll post my Discord real quick. You can hit me up, man, because I'm down to learn shit. Like the odds that that you'll convince me that the
I'm not going to convince you.
No, not you. I'm talking to Sarav. So as long as you're just like trying to explain stuff how you see it or whatever, like I'm good with that, dude.
Yep.
Because maybe
I have to grade the exams. I have to create the exams, which I was scrambling to get done today, and then I have to grade the exams. Yeah, and let me repeat that too.
So
we're not going to change each other's minds.
Yeah.
What I want out of this is to explore how you approach a question like this, and to contrast it with how I approach that same kind of question.
Okay.
Right. So, for example, you've said like gravity, the force is really, really small. Right. My phone and my pen are supposedly attracted to each other by gravity.
Mm-hmm.
But I don't see that happening. I can't feel that happening. Right? Maybe I'm going to say I don't believe it's happening. Right? Okay. How do you then proceed? What was your next step?
I don't know what the next step is, man. Like do
you believe bacteria exist?
Yeah.
Can you see
them? You can see it grow. Yeah.
Can you see them?
Yeah.
As individual little things?
Oh no, but you could see like when bacteria is growing on something, like like it eventually, like you know that there's something there doing that, right?
You know there's something there when you see it get big. When the bacteria are just individual bacteria, you can't see them.
Right.
But when they get all together, you can see them.
Mm-hmm.
Right.
Yeah.
And you're cool with that.
Yep.
So when gravity is real small, you can't see it. But if it gets real big, you can.
But okay,
but that's not cool.
No, because it's like you're saying, that. I guess it's just the difference in, you're saying that it affects it directly proportional to the size of the thing that it's affecting, right?
And the mass, yes.
Right. So I guess that kind of answers it. I don't have anything other to say about that. You got me on that one. Because I feel like if it was affecting stuff on that level, that it would have to affect us harder than what it does. That's my line of thinking on it. Because you're saying because like the sun, right? So 93 million miles away, like it's pulling on us and all this shit and dragging us through, whatever we're allegedly moving through, but it's not. With like nobody, can we feel that or measure it other than just? So that's where I'm just like, what is this, man?
Right. And that's the difference, right? That's the difference. I think there's three kinds of people.
Mm-hmm.
There's one kind of person who says, can we feel the sun pulling on us? And they go, let me find out. And then there's another kind of person who says, can we feel the sun pulling on us? Man, I don't know. Who cares? Right? Let the scientists deal with that. Whatever the scientists say, that's fine with me. And then there's the other kind of person who says, can we feel the sun pulling on us? I don't know. So therefore there's no gravity.
Well, not that there's no gravity, but just how it's described. Because I feel like you're adding. I feel like you're adding additional stuff to it beyond what we can observe on Earth. That's all I have to say about it. Because I feel like you're attributing.
Well, I say that we're not.
I mean, I feel like you are, and that's why they have to fake the videos of space, because that shit don't exist the way it is.
How much research have you done to find out whether we can observe gravity on Earth?
Well, I've asked you about it, and the best you could come up with was the Cavendish experiment.
The Cavendish is the best. It's by far the best. There's more, but it's by far the best. So if you don't like the Cavendish
Yeah.
I think that what we see here is a serious bias in your selection.
Yeah,
Like,
from my
I like
understanding,
Cavendish and you don't.
the only thing you had was the Cavendish. So I didn't know that there was others. Can
Oh,
you direct
there's
me to?
tons. Yeah,
Can
there's
you?
tons.
What do you got? Like what are?
What have I got? I've got a video I don't much like, but there's an old video, like there's old film reel is what it was, of a science demonstration where a guy just has a scale, he has a mass hanging from a scale, and then he puts a big mass underneath it, and you see the weight increase on the scale. We got that, and then actually the one I like the best.
Dude, I think I've seen that video actually.
Yeah,
And
and
there
I'm like, come on, man.
dude, yeah, I was reading the comments on that because I'm not sure if it was the same video, but that sounds so familiar to something when I was looking into the Cavendish stuff when you told me about it. Because I genuinely didn't. I was like, I'd never even heard of that
Yeah.
until you said it. So one sec. What was I guess? Oh, I was reading the comments on that video or a video like that where with the mass under the thing and it weighs more. And like, there was mad people in the comments, going, "Hey, I'm an engineer, blah blah blah," and and the math doesn't, work out on this. So like, this isn't actually, proof. So I didn't know how to really interpret that because I kind of felt the same
Me
way about the
either.
Cavendish. It's just hoodly daddle, really.
I haven't.
Me,
I have done the math on the Cavendish experiment. I have not done the math on the one that I mentioned. I just mention it because it does come up. I don't know if it's any good or not. What I do know is good is there's one from Sarov here. I put in the banner, which is PhD Tony uses something called a gravitometer, and that's what he does for a living. He uses these things to find minerals. He works for a big company, and they're looking to mine and find something valuable. And how they do it is by finding its gravity. It's heavier. What they're looking for, I think, is heavier than the rock that it's within. So they look to find the ore, they look for dense places under the earth, and they use little gravity detectors for that.
can you do you know exactly what he uses? Like, is there like a model number or anything like that, or does he have a
He's
YouTube
given it. Does
channel?
anyone happen to know?
Because I would be interested to look up like the device and stuff and how that works. Because I've heard of the gravimeter stuff before, and I haven't really looked into it.
Okay.
I just but that's interesting that they're using that to find stuff that's in the earth, right? I'm assuming.
Sure. And of course, you don't believe in in space and space flight. But one of the folks that I actually know, one of my neighbors, worked on the GRACE project, which is a satellite. It's a pair of satellites that was used to map the gravity all around the Earth and how it has tiny, minute variations everywhere on the Earth. But of course, you don't want to believe in that because it's from NASA, right?
Right.
Which I understand. I dig that. So let me just suggest a simpler one, which is drive around with a scale. Drive around the country with a scale and tell me, does your mass weigh the same everywhere on the Earth? It shouldn't. Does it?
Don't know. I haven't been around. I haven't done that.
Yeah, Bob the Science Guy. You know who Bob the Science Guy is?
Heard of him?
He's pretty pleasant. He's a glober, right? He's an anti-flat earther, and he drove from Michigan to Florida, I think. And every few hundred miles, he stopped and weighed his mass, and then drove back home the opposite direction, and published all the data. So, yeah, something just any old buddy can do.
Yeah.
Just a dude with a car and a scale, right?
Gotcha.
It's out there. It's not hard. And probably another one I'll just throw at you because you want to know. I think it was MIT. Was it MIT? Not that long ago. Shot. I think was it gamma ray? Somebody remind me. I see Middlewell's in here. I'm sure you remember what was the frequency that they used? They shot light. They shot, radio light upwards and then bounced it back downwards. And they measured the difference and found that sure enough, the light is having to fight against gravity on the way up, and it's getting the benefit of gravity on the way down, just like Einstein said.
So wait, I thought, hold on.
The frequency shifts on the radio waves.
So would that be like a speed change? Is that what you're saying, or?
It's the frequency that shifts.
Well,
it's complicated.
What does that mean exactly?
Grad student science stuff.
Well, give me your best TLDR.
Well, that was one of the big differences between Newton and Einstein was, according to Einstein's numbers, his equations, light would be bent by gravity, right? And Newton really didn't know. Newton kind of thought it would be, but in a different way. So they had a difference between what they thought light would do. And so then we measured it and we found out it works like Einstein says. And so light is bent by gravity. And so if you shoot light, like if you shoot light across a gravity field, it bends, it curves, right?
What gravity field did they shoot it again across?
The sun. Or? The first discovery was the sun.
Do you have is there some? What was that experiment called again? That was from MIT, you said?
Oh, well, the MIT one, they just shot it straight up a tower. They knocked holes in the floor. They had some old tower that nobody was using, and they knocked holes in the floor.
Oh, okay. Yeah, I'm sorry. Who did the sun one? What's that about? Who?
That was 1919. And who was it? Somebody remind me. We can look this up. Who was it? It was somebody famous, and I'm blanking on who it was. It wasn't Einstein, didn't do it himself. Somebody else did the experiment, and they watched the light from a star behind the sun during an eclipse and watched how the star moved. And yeah, I mean.
Oh, wait. No, I've heard of that. So you're talking about okay.
Eddington.
So,
I think it was Eddington.
So what if the sun's got a magnetic field, right?
Yes.
A magnetic field would bend light too, right?
No.
No? Okay.
No. Not as far as we know, right?
I don't know. Is a magnetic field?
Right. Not well. And this is the deal. The way science is supposed to work is we make a guess, right? It's an educated guess. We take everything we know and we say, if we've got this right, this is what should happen. If my guess is right, this is the way it should work. Rusty says, Eddington, Dyson, and Davidson. That's the name of the, I'm going to believe you. I definitely remember Eddington.
Yeah, Eddington sounds super familiar. So but real quick though, I just Googled, does a magnetic field bend light? And the first thing that came up was saying that, it does.
Oh, okay.
Or can. So my question would be, how, if the sun has a huge, it probably would, if it's what do you guys say it is, 800,000 miles big or whatever. So it probably has like a really big magnetic field, right? So couldn't that have also been what bent the, and not a quote unquote gravity field?
It may be, but here's how science works, right? We say, if I've got this right, this is the way it should work. And then you go and you look and you say, is that what happens? If that is not what happens, then you go back and you say, no, I got it wrong, right? And then if it does work the way you thought it would, okay. Jezza has something for you, but we'll get back to it. If it does work the way you say, that doesn't mean you're necessarily right, but it means it's looking good for you so far. You can keep on going with the equation that you've got. The equation that you've got works so far until somebody comes along and says, no, I got a better one, right?
Yeah.
Okay.
No,
So
I'm
what does
with you.
Dumjeza say? And this agrees with my understanding as well, which is that a magnetic field does not affect the photons of light directly. However, a magnet can distort the medium through which light passes and thereby bend the light rays.
Okay.
So that's what he says. And Michael Olson here says light has no charge, so it should not bend in an EM field. That's my understanding as well. So yeah, I don't know. But yeah, when you come back with, yeah, but maybe it's this or maybe it's that, I'm going to say the scientific principle says, well, yeah, maybe, right? Maybe if you think it is, the way you go next is to say, the way I think it works is this. And then we design a test to tell the difference, right? That's what the Einstein test was about. It was Newton thought light would bend around the sun this much. Einstein thought the light would bend that much. So then they measured it and they're like, what did we get? We got Einstein's number. And so we're like, okay, Einstein's the winner. Einstein's equation is better than Newton's equation.
Okay.
And that's how it works, right? And then you come along and give me a better one. We'll replace Einstein's with yours.
Gotcha, dude. Okay.